So, hi guys, today's video we're going to do the chapter summary of the chapter 5, which is Ethernet encapsulation. So, let's start. So, before we start, Ethernet encapsulation is the most widely used LAN technology today. Ethernet operates in the data link layer and the physical layer. It is a family of networking technologies that are defined in the IEE or IEE 0802.2 and 802.3 standard. So Ethernet support data bandwidth of 10 Mbps or megabit per second and 100 Mbps and 1000 Mbps, 10,000, 40,000, and 100,000. So data encapsulation. So the data encapsulation is a process include frame assembly before transmission and bring um, bring the assemble upon reception of a frame in forming the frame Mac layer adds a header and trailer to the network layer PDU. And so we have the frame delimiting, which is the framing process provides important delimiter that are used to identify a group of bits that make a frame. So these delimiting bits provide synchronization between the transmitting and receiving nodes. So the addressing is the encapsulation process contains the layer 3 PDU and also provides the data link layer addressing. So error detection is each frame contains a trailer used to detect any errors in transmission. So Unicast MAC address. So a Unicast MAC address is the unique address used when the frame is sent from a single transmitting device to a single destination device. So the second one is the broadcast MAC address. So a broadcast packet a broadcast packet contains a destination IPv4 or Internet Protocol version for address that has all ones and in the host portion. So this numbering in the address means that all hosts on the local network area or broadcast domain will receive and process the packet. So many network protocols such as DHCP and ARF use broadcast. So multicast. So multicast addresses allow a source device to send a packet to a group of devices. So device that belong to a multicast group or assign a multicast group address. The range of IPv4 or Internet Protocol version for multicast addresses is 224.0.0.02 239.255.255.255. Then the range of Internet Protocol version 6 multicast addresses begin with the um, FF00 double semicolon slash 8 with the prefix of 8. Then because multicast addresses represent a group of addresses sometimes called a host group, they can only be used as the destination of packet. Then this source will also be unicast addresses. So the next one will be the cut-through switching. So in cut-cross switching, the switch act upon the data as soon as it's received, even if the transmission is not complete. So the switch buffer just not enough of the frame to read the destination MAC address so that it can determine to which forward the data. So the next one will be the duplex and speed settings. So there are two types of the duplex settings used for communication on an Ethernet network: the half duplex and the full duplex. So the full duplex is a both ends on the connection can send and receive simultaneously, while the half duplex is only one end of the connection can send at a time. Excuse. So the next one is the introduction to ARP. So destination MAC address is the MAC address of the Ethernet NIC, which will be either the MAC address of the final destination device or the router, the source MAC address, or the MAC address of the sender's Ethernet NIC. So, that's the end of the PowerPoint presentation for the summary of the chapter 5. Then let's go to summary of the NetAcad. So chapter 5, Ethernet. Ethernet is the most widely used LAN technology today. So it is a family of networking technologies that are defined in the IEEE C802.2 and the 802.3, as I've said a while ago, standard. So Ethernet as standard define both the layer 2 protocols and the layer 1 technologies. So for the layer 2 protocols, as it's all 802 IE standard, Ethernet relies on the two separate sublayers of the data link layer to operate the logical link control, or the LLC. So, and the MAC sublayer. At the data link, the frame structure is nearly identical for all the bandwidths of Ethernet. The Ethernet frame structure adds header and trailer around the layer 3 PDU to encapsulate the message being sent. So, there are two styles of Ethernet framing: IEEE 802.3 Ethernet standard and the DICS Ethernet standard, which is now referred to Ethernet 2. Then the most significant difference between the two standards is the addition of a start frame delimiter SFD and the change of the type field to a length field in the 802.3. So Ethernet 2 is the Ethernet frame format used to TCP, or Transmission Control Protocol, or IP network, as implementation of the IEEE 802.2 or point 3 standard. The Ethernet frame provides MAC addresses and error checking. So the layer 2 addressing provides by Ethernet support unicast, multicast and broadcast communication, and Ethernet uses the address resolution protocol to determine the MAC addresses of destination and map them against Internet Protocol version 4 addresses. Each node on IPv4 network has both a MAC addresses and the IPv4 address. The IP addresses are used to identify the original source and final destination of the packet. So the Ethernet MAC addresses are used to send the packet from one Ethernet NIC to another Ethernet NIC on the same IP network. So ARP is used to map a known IPv4 addresses to MAC addresses. So the packet can be encapsulated in an Ethernet frame with the correct layer 2 address. So ARP relies on a certain types of Ethernet broadcast message and Ethernet unicast message called ARP request and ARP replies. The ARP protocol resolves Internet Protocol version 4 addresses the MAC addresses and maintains a table of mapping. So on most Ethernet network, and devices are typically connected on point-to-point basis at a layer 2 full duplex switch. Then a layer 2 LAN switch performs switching and filtering based on the OSI data link layer 2 MAC addresses, and a layer 2 switch builds the MAC addresses table that uses to make forwarding decision. Layer 2 switches depend on routers to pass a data between independent subnetworks. So now that we read the summary for the chapter 5, uh, thank you guys for watching. Hope you learned something about my video, and thank you.